Okay, so now let's come back to expressing a language model, or rather an autoregressive language model as an RL policy. Right, for all the theory that we have seen so far to be applicable, we need to first express an autoregressive language model in terms of an RL policy. Let us see how would one do that. So what do we need? We first need to see a language model in terms of uh, an RL policy. So what is done in in an autoregressive language model? What we predict a token xt given the historical tokens. Okay, right, this is what we do, which is we are modeling p theta of xt conditioned on everything that is less than t. This is what we do, right? In the context of reinforcement learning, the language model itself is taken as a policy. Right, policy pi theta. So pi theta of at given st. Right, the trained language model is which is p theta of xt given xt less than t itself is considered as a policy. And it makes sense because what we finally want to optimize is the language model, and in the RL framework what we are optimizing is the policy. Therefore it is natural and obvious to consider the language model itself as a policy, right? Okay, so now to apply the policy gradient optimization, what we need is a trajectory. For to apply RL, we need a trajectory. So how do we define a trajectory in a language model? Is as follows. So in a language model, we need a trajectory. Let's write it as tau is equal to S naught, A naught, and we have S1, A1 and so on. So we need a trajectory of this sort. In a language model, the trajectory is given as the follows. The initial input tokens, or let's call this as prompt, right? I mean, you give an input to a particular trained language model, which is called as the prompt. You take this as S naught. Okay, A naught is, or rather the first token, the first output token is taken as A naught. Okay, then the prompt plus first output token is itself taken as S1 and so on. So we do it cumulatively. So what is this? So now S naught plus, so we have S naught is the input to the language model, and A naught is the first output of the language model. Okay. We have S0 plus S0 and A0 concatenated, which is the prompt and the first token that is given, first output token is taken to be S1, and the second action is the second output of language model, and so on. So this is how we build a trajectory that is required for any RL based algorithm to be applied in the case of a language model. So the policy itself is taken to be the language model, or the language model itself is taken to be the underlying policy that we would want to optimize. The trajectory is built that way. So the input is taken to be the first state. The first output token that is generated out of some inference process from the language model is taken to be the first action. Now you concatenate the input and the first output token as, and that constitutes the second state. And given that second state, the language model outputs another token that becomes the second action. Concatenate that with everything that is before, that becomes the third state, and so on. So that's how you constitute a trajectory in the case of a language model. Now once the trajectory is constructed, it is easy to use the policy gradient theorem to find a better policy by gradient descent method that we just showed.